A company's records indicate that on any given day, about 4% of their day shift employees and 7% of their night shift employees will miss work. 70% of employees work the day shift. So if 70% work the day shift, 30% work the night shift. So if 4% of the day shift miss work, 96% don't. If 7% of the night shift miss, 93% don't. And then we can go ahead and multiply to get all of our combinations. And we kind of need to answer part B to get part A. What percent of employees are absent on any given day would be the sum of our two absents. Okay, as a decimal, that's 0.049. So as a percent, it'd be 4.9%. Okay, so now to do part A, if we take 0.028 out of 0.049 or 0.021 out of 0.049, do we get the same thing? We do not, so it is not independent. Pay attention that you write that as a percent. When I did the test, I wrote it as a decimal, so I got it wrong, even though my work was right. On any given day at some company, about 3% of the day shift employees and 10% of the night shift employees are overtired. So that means that 97% are not and 90% are not. What percent of the overtired employees are on the night shift? So we need to find out how many employees are overtired. So if we multiply 0.7 times 0.03 and 0.3 times 0.1 and add those two together to get the total number of overtired people would be 0.051. A study concluded that among people with a certain virus, 99.2% of the tests conducted were correctly positive, while for people without the virus, 97.7% of the tests were correctly negative. If 25% actually carry the virus, what's the probability that a patient testing negative is truly free of the virus? Okay, so that means 75% do not have it. And they told us that it was accurate for positives 99.2% of the time. So if we take 0.25 times 0.992, we get 0.248. So they get a negative result when they're actually positive 0.02 of the time, so 0.2% of the time. So either you could subtract 0.25 minus 0.248 or do 0.8% of 0.25, get the same thing either way. And so same thing with the no virus, it is a correct negative 97.7% of the time. So 0.75 times 0.977 is 0.73275. Okay, so then to get when they test positive and they don't have the virus, that only happens 0.01725. Okay, so the question is, what's the probability that a patient testing negative, so we're down here, is truly free of the virus? Okay, so we want them to actually have no virus. That's our positive result. So probability is favorable outcomes. out of total, and when we add those two together, we're going to get 0.73475. And divide, I get 0.997 to the nearest thousandth. Police often set up sobriety checkpoints, roadblocks where drivers are asked a few brief questions to allow the officer to judge whether the person maybe have been drinking. If the officer does not suspect a problem, drivers are released to go on their way. Otherwise, drivers are detained for a breathalyzer test that will determine whether or not they will be arrested. The police say that based on the brief initial stop, trained officers make the right decision 80% of the time. So that means they mess up 20% of the time. Okay, safety experts suspect that about 17% have been drinking. So 17% are drinking, that means 83% are not. For A, a statistics student is stopped at the checkpoint and of course has not been drinking. What is the probability the statistics student is detained for further testing? Okay, this one, to get their answer, they just said, hey, the cops were wrong because they weren't drinking. So to be wrong, it is just straight out 0.2 because we already know they're not drinking. Okay, next they ask, what's the probability that any given driver will be detained? Okay, so if the cops are right, they only detain, so the right, they will detain people that are drinking, so that's 0.136, plus sometimes they will incorrectly detain people that are not drinking, so 0.166, add those up, and we get 0.302. Okay, of the people they detained, 0.136 out of the 0.302 were drinking. So to the nearest thousands, that's 0.450. On the other side of the coin, when they're right, there are people that were not drinking and there are people that were drinking. So the probability a person who was released was actually drinking, so 0.034 out of the total of 0.698 is only 0.049. So they're doing a pretty good job on the sobriety check.